is associated with the grid, it becomes smart, right? So that is a job of engineer. Means everything is already there, but we are trying to make it better and better continuously, right? So that is what means what doctors are doing. They are doing when we are not well, so they are treating us. But what is the job of the engineer? That when we are fit and well also, so how we can make our life better or more comfortable. That is the job. Everything you see around you, whatever is giving you more comfort, is the job of the engineer actually, right? So as you can see, if it is not there, so if you think earlier we used to go from one place to another place using a belgadi, right? Otherwise, before that, everybody was going by walk only. So the grid is already there. We are making it in smart. So we are making it better and better. So that is required also. If you think today, if IT technology was not there, or ATM facility was not there, so what would happen in the banks, right? There will be a very long queue. Everybody might be waiting, and it would have been almost impossible to work in the bank, right? Because you can imagine, means I think you might not have seen that those long queues if we talk about 20 years before this, so when there was no IT technology, no ATM was there. So everything is to be done by making a queue in the bank, and even computers were not there, so they used to fill the passbook using the pen. So what same work was being held earlier also, but now they are doing with the help of IT technology and using computers and very other things, right? So you can very easily go to the ATM and withdraw your money without any manual interference also. So man is not there, but work is being done. So same thing we want to incorporate in our electric grid also. So what is happening means without a smart grid, everything is manual. Suppose there is a fault, normally the utility will not come to know that fault is there, and you will call them that electricity is not coming to our house. So then they will try to find out where is the fault, and they will come manually and try to rectify the fault, and the electricity will be restored. So a lot of problems are there. So reliability is not there, frequent faults are there. So as load is increasing day by day, these problems are more prominent, you can see. So if we don't go for the smart grid, the problem will keep on increasing. So there is no other option. As the bank is adopting IT technology and they are using a lot of bills you are paying through internet only. So you don't have to go for that queue, and that problem is now simplified. Similarly, whatever problems are there in the conventional grid will be rectified and will be improved. All functionality will be improved if we make the use of digital technology or IT along with the smart grid. So all means various communication equipments will be connected, and yeah, means making the grid smarter. So smart term is very common now. A smartphone you are using. Smart means it is using its own database, previous experiences being stored, and based on that previous experience, the computer and the program is able to take some decision and um, take action accordingly to rectify any problem if they're in the smart grid, right? So if you see the slide here, so electric grid, I told you the digital technology that allows two-way communication between the utility and its customer, and sensing along the transmission line is what makes the grid smart, right? So earlier means this was not there, right? So what was the vertical arrangement was there? So power was flowing from generation to the consumer only. So that was one-way communication, not only in terms of electricity, also in terms of the communication, right? The signals which are coming and checking everything. So two networks are working simultaneously. One is communication network, one will be the electrical network. So the communication network will be providing data from consumer to the utility also, from utility to consumer also. So two-way communication is there, and two-way flow of electricity is also there. So both are two separate networks will be there. One is for sending data or signals, one will be for sending or receiving power, you can say. So now why it is two ways now means because of the introduction of the renewable energy, right? So very soon you will see a drastic change in this field also. You might have seen the rooftop solar plants are being installed, also, and government is also installing large power plants, solar and wind plants are there, right? So they are solar and wind farms they call, right? So amount of power is being generated and that is connected to the grid. So very soon means things will be, there will be drastic change in the field of power system, you can say. So the smart grid will consist of controls, computer automation, and new technologies and equipment working together, right? So there are equipments also which are sensing and sending data to the utility, and accordingly utility is taking decisions. So these technology will work with the electrical grid, respond digitally to our quickly changing electric demands to deliver electricity efficiently, reliably, and securely, you can say. So that is a job basically. So we want to improve the efficiency. We want to improve the reliability, means less number of power failure should be there, and electricity should go to the consumer. So that is means for 24 hours. So we want to make, that is the target actually. Securely means security will also increase. Means if we talk about the transmission system, right? So normally there are not much problem in the transmission. Power is flowing, but due to some major outage, suppose generator failure is there, or major load is disconnected suddenly, so there may be a problem of synchronism, and that may be means right. Yeah. So based on that, synchronism is lost. One more generator will be there in outage, and in as a sequence, there will be a complete blackout also. So there are so many examples. But that's the rare event. But as the load is increasing, population is increasing, the affordability of the consumer is also increasing. So they are now, earlier they were not, even the people were not having cooler in their home. Now everybody is installing AC, right? So industry is also growing. So when power demand is growing continuously, and if we talk about the conventional energy only, we will not be able to supply the energy that demand based on the conventional sources. Means now environment is also is a major cause. Now a lot of pressure from the environmentalist also to reduce the carbon emissions. So we cannot depend on the thermal power plant only. So that is being discouraged nowadays. Means a lot of, right, carbon emission is there. So that is harmful for the environment also. So we have to go for the renewable energy. That is the demand of the future. And but when we are going for this, a lot of new challenges are also coming, right? So solar is generating power in DC. So you have to convert it to the AC. But when you are converting, the harmonics will come, and a lot of other problems. So means that the conventional generators are having rotating part, so that inertia is there, and that is means for stability it is very useful. So static device is not having that part. So that is again creating a problem. And I'm just discussing in general. Slide maybe showing something else, right? So another problem with the renewable energy is that it is intermittent, means we cannot fully rely on that also. So it depends on the weather, right? You cannot predict the whether the sun will be available tomorrow or not, right? You're not that sure what amount of power will be जस्ट मिनट, अपना फोन साइलेंट ही कर देता हूँ. So that is what is going on. So basically, the purpose of these type of faculty development program is that you will have some research ideas from this. So many research objectives you can find out in this presentation. So the details you can explore in the basic idea, you can get it here, and you can see the research papers available in the literature based on those topics. So research is going on. So there's a lot of areas you can explore in this area. So when we are changing the conventional grid to the smart grid, lot of components are coming, right? So another term is smart grid means making the means clean energy. I was talking about a clean energy. That means we are using uh, renewable energies in the smart grid also. So it is a modernized grid that enables bidirectional flow of energy and use two-way communication control capabilities, and that will lead to an array of new functionality and application. Right, conventional power grid primarily delivers electricity in one-way flow from generator to the outlet. The smart grid will permit two-way flow of both electricity and information. As I told you, both the things will be having two-way flow. That is the main purpose of the smart grid. It's not changing. Okay. This is an conventional grid, you know. So one-way electricity from generating station to the consumer. So centralized bulk generation, right? So generation was there only in the generating. Large power plants are there, and they are supplying the energy to the consumer. So it has to flow through the transmission line and through distribution network and coming to the consumer, right? So on the way, a lot of power loss is there in terms of it. So responsible for 40% of human cause CO2 production also, right? So that is another problem in this. One is that the power is coming far away from large power plants to the consumer. So on the way, a lot of losses are there in terms of I square R losses, right? Sorry. A lot of CO2 production is there. Controllable generation and predictable loads, right? Size of the infrequent peak demand operates at 50% capacity, right? So what is the problem? Means you are installing power plant to meet that peak demand. That is for very small duration, basically. Otherwise, the power demand, to meet that power demand of peak demand, you are installing generation of that capacity. Otherwise, the you are means operating at 50% capacity only. And just to meet the peak demand, the capacity you have increased. So otherwise, so and inefficiently you are means producing power actually. So limited automation and suitable awareness. Automation is almost nil or limited is there, and lots of customized property system. Right, lack of consumer side data to manage or reduce the energy use. All these problems are there, and why we are going for smart grid. So I already introduced the conventional electric grid are insufficient network, highly prone to power failure. It has become stress grid structure, right? And as because the load demand is increasing at a faster rate than energy supply because of the increase in the population, with increase in the energy cost, load is also increasing. So all these are means making the grid more stressed. So stress grid structure is there. So we have to go for the smart grid. Supplying to this demand by increased generation at the power plant is needed. So one other solution to this problem is by distributed generation. So this is distributed generation. So what is happening? Earlier the power was generated from the generating station and coming to the load. So now distributed generation means you are generating at the load side there and then in there itself, right? Power is being generated near the load and that will be means suppose power plant means distributed generation. Here you are having solar power plant or wind near the load, so that will be supplying power locally to the load. Suppose you are having a solar plant at rooftop. Similarly, means other plants also near the load centers. So that power will not be flowing to the long transmission line. So that will be locally. And when we are meeting some load locally, so load on this generator or transmission line will also reduce. So indirectly the capacity will increase. Otherwise, you would have to install a new power plant there. So you don't have to go for that. So indirectly, a lot of advantages are there. So distributed generation is at a load end by solar, wind, other sources, and this two-way generation can compensate the increased load demand, right? So this way means you are generating sub load locally near the load. So indirectly, the stress on these generating station is reduced, and indirectly the demand is met, right? So both way it is useful, means advantageous. Conventional grid system is unable to control a two-way. So that is now two-way. Now sometimes generation is from this side to this side also, from this side to this side also. So you are generating at the load center also. So that is two-way generation. So conventional grid system is unable to control two-way supply power due to the complexity, and the concept of smart grid is needed. So conventional grids were not designed to handle this two-way supply. They are completely designed based on one-way power supply only. So now new challenges are there. Means when smart grid is there, two-way supply of power is there. So the protection system, the control system, everything will change. So a new research area you can find in this area also. So this is what the smart grid concept, the basic idea. Earlier transmission system is there, generation is there, but we are introducing solar and wind along with this also. So large solar plant which the government is installing. Now distribution is already there, consumer is there. So consumer is also generating power because he's installed solar plant also, he may install wind also. So consumer is also generating power. Government is also installing renewable energy. Market is there. Market is there for deciding the rate of the. So this is another area of research. Means what will be the price of the electricity, that can also vary, and depending on the demand or the season or the availability, you can change the rate of the electricity, right? So what will be the rate? Means there earlier what was there? Only government was supplying the electricity, right? Now the deregulation is taking place, means government is modifying their laws. Earlier, the private vendors were not supposed, they are not allowed to generate the power. Now the situation is that when demand is increasing, the government has to change the regulation. So deregulation is taking place, and the debundling is also taking place. Earlier, the complete electricity board was there, which was combination of transmission, distribution, and generation. One board was there. So company utility is also divided there into a smaller company. Means transmission company will be different, distribution company, Discom will be different, Gencom will be different, Transcom will be different, right? In Rajasthan, we are having Jaipur Discom, Ajmer Discom, and Jodhpur Discom. So three Discoms are there. Generation is a separate company. Transmission is a separate company. So they are handling their own problems separately. Earlier, it was a one board. So why we are deregulating? This is known as deregulation. So they are means modifying their laws, and now means private vendors may also come. They can sell their electricity at their own price. So right, so they will bid their price. Yeah, I will be supplying this electricity at this price, but my advantage will be this. Yeah, there will be no voltage problem, or reliability will be 100%. Some will say reliability is not 100%, but my price will be low. So based on different condition, different vendors will be providing electricity with different condition. So depending on your need, you can choose the electricity. If you compare with this the telecommunication system earlier, if I talk about 25 years before this, you might not be knowing. Means there were so many STD booths were there. So we have to, if we have to call to other city, we were waiting till night. When rates will be reduced, we will call. And STD booths were there. They were displaying the cost of telephone call actually. So you, when you are calling, you are looking at that meter also, how much price is now. So you try to finish your call in minimum time so that the cost should not increase. Now you see what happened. Earlier it was only BSNL, means government was having that communication system, so they were having their own price. When competition is there now, private, means you can say mobile has come and Airtel is there, Vodafone is there. So many competitors are now there in the market. So the cost of phone call is now reduced a lot. Now you don't think when you have to call, you can just pick your mobile and you can call anytime. Even international calls are very easy to adopt very easily. Means the cost is not that high. Earlier, STD was also a very costly affair actually. The same thing will happen in this when competitors will come. Other private vendors will also come and they will also supply their energy. So market will be required. So everybody will be selling their electricity at different prices in different season, right? Even consumer can sell their energy. Means you are generating some power when it is not required in your house. You will be selling it to the grid. So you will be having a two-way meter there that will be recording how much energy you are purchasing, how much energy you are selling. Also that is also being recorded. So when a generation in your home is surplus, you will be supplying the energy to the grid and you will be earning money on the basis of that. Right? So computer operators also there, service providers are also there. There's a utility which is providing energy to you. Some other private vendors may also be there. So you can see these are the electrical flow. This is the communication flow. So all these are connected. Data is coming from here to where the blue lines are showing that everything is being, means market, they are telling you the price of the electricity here, and based on that you can take change your schedule, right? That is the call, that is called a demand response program. So we will be discussing all this in the forthcoming slide. Now again some diagrammatically representation of means conventional grid and microgrid, you can say. So this is communications infrastructure and this is power infrastructure. So two-way flow of electricity and information is shown in this diagram, which we have already discussed. And now what are the advantages of the smart grid over the traditional grid? The more efficient transmission of electricity, thus lowering the generation requirement. Right? If you increase the efficiency, otherwise what, suppose earlier the efficiency was 80%. So to meet that demand, you have to increase your generation. So you have to install new plants, you might have to plan for new generating station or new unit, you can say. So that you don't have to plan. If you are increasing the energy efficiency from 80% to 90%, so some demand you can meet with the same emitting units. So just by increasing the efficiency, you are means lowering the generating requirement also. In that way also you are saving some money. Quicker restoration of electricity after power distribution by providing detailed information, right? So means when a fault is there, the restoration time was more earlier, means because everything was manual or exact location of the fault is not there. Whether there is fault or not, that is also known to the utility. So some consumer only will inform that fault is there, so they will come manually and try to rectify that fault. Now everything is now available and the information is not available, right? So that information may come before the fault occurs. Means the complete the transformer being, some equipment is being installed in the transformer. If it is some problem in the function of a transformer, so that information may go to the utility earlier also, right? or when fault is occurred also, then also immediately the information will go to the consumer. You can save the theft also by sending the details through communication. So every data is going to the utility. They can check that data. Means suppose um, everything is coming to the utility. Means transformer, how much power is being supplied by a transformer, is information is coming to the system, and how much power is being utilized by different. Suppose that transformer is connected to 100 users. So what is the sum of those 100 users? If it is not matching, means some theft is there, and that can also be located. So you can make some system which can locate the fault also, right? So now this thing. So if you talk about the transmission system, and if data is available, the history data is, means everything is being recorded, and in any particular instance, means fault was occurred and asynchronism was occurred and blackout was occurred. So what was the cause? So that data is also being stored, right? So there are tools you can use the previous data, like ANN is there. You can train your system, so that will decide. You can artificially create fault in the computer itself. Means suppose the fault actually it has not occurred, but you are creating fault in your system. The data is being fed into computer, and they can analyze that if fault occurs at this particular instant, whether there will be a problem of synchronism or not. So that way you can see. So based on the historical data, you have trained your network, and that trained network can predict the result for unseen data also in future. So if that train data is available to the utility, and they can continuously check whether at this present situation, whether there will be a problem of asynchronism or a fault occur, although the fault is not occurred. So they can see if fault occur at this particular moment, will it be able to sustain that fault? Will be stable or not stable? So accordingly, you can take action before the fault occurs. So before it happen, you can analyze what will happen if fault occurs at this particular moment. So you can take action accordingly. If some load is to be shut down, you can shut down, and you can save that emergency situation based on the data. So that type of thing can be done. Means if data is available, the your program is there, your means control action is there. So sitting in your control room, you can control everything. Means before that fault occur, you can take some action and avoid that situation. So reduce the operation and management cost of utility also, right? Some tasks are being reduced. Means naturally when computerized system is there, that is being opposed also, because when suppose like, one particular company installs some computers, so that the number of employees required will also be reduced. So many tasks will be done by the computer only. So otherwise that it was being done by the human being. So it means your number of operations are also reduced. Means some of the tasks being done by the, otherwise in manual system, some of the tasks will be done by the manpower. So some tasks will be done by the computer, so that it is reduced. It will reduce the management cost also of the utility, right? So indirectly, in terms of money, you will be saving some money. Indirectly, it will be beneficial for the consumer. Means when generation cost is reduced, naturally cost of electricity will also reduce, and utility lower power cost for the consumer. So in the same way, consumer will also be having advantage. Reduce peak demand. You can compare with the telecommunication system. Means अभी पहले cost कितनी ज़्यादा थी because of the competition, because of the IT, because of the mobile facility, because of the competitors in the market. The cost of telephone is now reduced a lot. So when private vendors will come, they will also supply electricity. The competition will be there. So definitely, cost of electricity will also reduce. So I suppose everybody is installing solar at their own house also. So some of the load is being covered by that solar power plant you have installed at your house. So things will change. Means you can compare with the earlier scenario also. Earlier means you can say the entertainment system. When we were there, we used to bring the video cassette on rent, right? Now, what happened after the CD come, all video cassettes were now dumped. So many business were closed. They were having very good business of supplying video cassettes of movies or so many things. So we used to bring those cassettes on rent. So we even the cassette player also on rent we used to bring, and we used to watch movies in the night. Right. So that scenario is now totally changed. You are having now digital media, means we cable which में आया था, that is also now not existing. So cable operators जो थे वो सारा business भी खत्म हो गया. So the scenario completely changes by new technology. Whenever new technology comes, the earlier system becomes obsolete. So you have to think for the future. So you can just see the revolution is now coming in this field of power system now, you can say. So very soon the scenario will change. You will see now everybody is having dish TV in their house. Now dish TV is also now nobody is watching. They are watching web series now. So using the internet, you can see those according to your convenient time. So you're not dependent on that particular time. It will come at 8 p.m. only, so you have to be free by 8 p.m. or 9 p.m. So now the concept of web series has come. So even nobody is watching cable TV or you can say dish TV. You can say. So scenario is changing but as the new technology comes. Similarly, whenever new technology will come, the complete scenario of power system will also change. So that is what the smart grid is doing. It is not at all smart. So we are in the process of converting the traditional grid to the smart grid, you can say. So increase integration of large scale renewable energy system, right? So it will reduce some environmental problem also, improve the management of distributed energy resources, including microgrid operations and storage management. So all these things are having their own research area. Suppose you are working on microgrid, so it's a complete other area. You can work on a storage also. How to manage the storage, you can say. When you have to charge a battery, when you have to discharge a battery, that timing if you manage, suppose there is a tariff of the electricity price at one particular time is very high, electricity price at some other time is lesser, so you will try to shift some of the load to the low price. So in that case means that is demand response. I will try to cover if time allows in my forthcoming slides. So all these things will be coming. So everything is a different area, you can say. Distributed energy resources is also an area where means what should be the location, what should be the optimal size of that distributed energy, right? That you can plan. So better integration of consumer owner power generation system, including renewable energy system. So consumer can also generate power. So he may be the owner also, a consumer also at the same time. He can be a producer also. So prosumer is a new term. We'll see in the next slide. Improve the security reliability by providing monitoring, analyze, and decision making, as I already covered. So smart grid will be complete having historical data also. It will continuously analyzing that thing, and decision making is there to taking control action in time. So your security system will be more secure and more reliable, you can say. Open a wider range of electricity pricing option, as I told you. So when competition will be there, private vendors will come in the generation. So electricity pricing option will be available to you. In Delhi, you can ask Delhi people; they are free to choose their supply vendors. I will take the energy from, as you said, I will. Now you can change your mobile supplier, no? Means by keeping the number same. Your mobile number will remain same. You can shift from Airtel to Vodafone. right? So it's up to you. Okay, I want to take that service now, if that is providing better option, right? Similarly, it will happen in terms of electricity also. The other vendor means any group is providing energy, better energy in lower price, you will go for that. Even if the price is higher and the quality is better, you will go for that. So earlier nobody was talking about the power quality, because whatever, only one vendor is there, only one option is there, whatever is coming to you, you are satisfied with that. So as a home consumer, you may be satisfied, but industries are having problem. Is there is a change in the voltage or change in the frequency, change in the power quality, so the production will be affected. So there is a loss in terms of money if voltage is fluctuating. So the power quality is a big issue nowadays. So you want not only कि आपके घर में power आ रहा है, light जल तो रही है, पंखा चल तो रहा है, it is not the issue. You want good quality also. There should not be a voltage fluctuation. So those who are having, means industry people, they know better ki what is the problem if the power quality is not good. Their production will be affected and there will be a loss in terms of money. So they want good powers, right? Good quality power. Power quality is also important. It's not ki power is, means what earlier utility was saying, that we are supplying the power is coming to you, it is 100% reliable, means 24 hours power is coming to you. But what was the quality? That was not the issue at all. Now it is a issue. So power quality is also important. So different vendors can bid their energy at different prices, right? So like this, things will be there. So you can work in electrical market field also, bidding what should be the best price. You can make your own strategy. So that will give you the best price of electricity and benefit to you. So again, there's in terms of definition. According to IEEE, smart grid is the large system of systems where each function domain consists of three layers. One layer is the power and the energy layer, right? Second layer is the communication layer, as I told you. Third is the IT or computer layer, right? So when second and third component are coming, so that is making this earlier system, because earlier system was only having this layer, power and energy layer. Now to make it smart, you have to add these two layers. So that becomes the smart grid, you can say. Now you can compare the conventional grid with the smart grid in this slide also. In terms of architecture, है ना, hierarchical or vertical structure is there, means generation, distribution, and generation, transmission, distribution. This was a vertical structure. Was one was. Now it is unbundling is happening, uh, right? And all these three components are being divided as Gencom, Discom, and you know, Transcom, and they can grow separately or horizontally. So this is known as deregulation system, deregulated and unbundled, you can say, or the horizontal system, right? So this is a change in the architecture. The consumer participation, non-participative and uninformed. So in this earlier system, we were not having any information, we were not informed, and we were not participating. Now we are well informed, means suppose the price is changing, so daily the price may change. You can have daily information ki at this particular time what will be the cost of energy. So utility will be informing you accordingly. You will change the schedule of your equipments to, like, you can change the timing of washing machine, you can change the timing of dishwasher, changing the watering system in your garden. So the load which are not, which can be shifted from one time to another. But you can, if you want to heat the water or anything, so you can reschedule according to the price of the electricity. So you are participating. So you can say I will participate in the demand response programs, and if the control is there with the utility, they can also cut your things, equipment. They can shut down from their control station directly, because you have given the consent ki I will be participating in the demand response. So if you are participating, some um, benefits may be given to you, extra payment may be given to you, because you are helping the utility to reduce their peak demand. So that is saving a lot of money to utility also. So they will be giving you some um, perks for that. If you're not participating, they can have penalty also. They can charge for that also if you're not helping them. So that way, demand response programs are coming. Different options are there. So that is again a different area of research. You can work on that. So generation and storage option in this central generator was there. Means the power plant hai वहाँ पे that is generating the big thermal plant or hydel power plant that is supplying the power. So central generator dominance was there. No storage framework was there in the earlier system. Now distributed energy resources are there with plug and play features. So you are having this. Now you think of means electric vehicles are also coming. That may be also my topic tomorrow. So distributed energy resources are coming. So your battery is also resource. So you can install in solar power plant, wind also at your home if you are having prominent wind available in that particular area. Solar availability is good, so you can go for solar power plant, and you can install battery also, right? That may be installed by the utility also and at the substation. So that way you are they are saving when energy in the surplus and it is not being used, so you can store that energy, right? Also earlier the storage concept was not there, so you can store that energy at that time, and you can use when the peak demand is there. When demand is less, you can store, and when demand is more, you can supply. So that way it is there. So you can suppose plug and play means automatically control where there. The battery can be work as a source also and as a load also. When it is charging, it is a load. When it is discharging, it is a source. So that control is automatically there. That is again programmed and controlled by your computer system. So when to charge, when to discharge. Suppose you feed the electricity price to the computer. So computer will automatically see. You don't have to worry about it. कि अभी price कम हो गया, चलो अभी charge कर लेते हैं. It will be done automatically. So you might have think of means अभी ये सारा कुछ आपके घर के भी है, AC वगैरह, fan है, everything you can control through computer. It will automatically do it. Some when automation system is something. Nobody is there in the room. Lights will be switched off automatically in big hotels or है ना, a big company. You can see that that control is there. When nobody is there, it is not being utilized. हम मैनुअली तो क्या है चलने दो, कोई स्विच ऑफ करता नहीं है. अभी हम क्लासरूम में जाते हैं, स्टूडेंट क्लास के बाद hundreds of students are there. When class is over, nobody switch off the fans and light. Although you write it in the room ki switch off the lights when it is not in use, nobody, they will read also, but they will not do it. But it should be automatic. Street lights are continuously running in the daytime also, you might have seen. So when human interference is there, that will not be done in time. But if it is automatic, controlled by the computer, so whenever means automatically sunrise is there, light is there, so automatically street light should turn off. And the night also, when not the traffic is not there, it should switch off. Means oh yeah, alternate on off हो जाए. When any vehicle is coming, automatically light should turn on. So whenever it is required, then only it should turn on. So we can make it automatic like this also. Street lights in the night are automatic. Suppose when car is coming, as car is coming, उसके आगे की लाइट ऑन होती गई, जैसे जैसे कार आगे निकल गई, पीछे की लाइट ऑफ होती जाएगी. This way also it may be there. So whenever it is required, then only you switch on, and it should be automatic. It cannot be manual. So a plug and play feature means everything is automatic. When it is not in use, it should be switched off. When it is in use, it should be turned on. Because now electricity price is very high. हम पहले जो एक valve use करते थे उसको बोलते 0 watt valve is there. Actually, it is not 0 watt, 15 watt. Because the price of electricity was too less. कि whatever electricity being consumed by the 15 watt valve is almost negligible. So we used to call it 0 watt valve. It is not 0 watt. Now we call it 15 watt because that is also, so you are going for LEDs, so that consume less amount of power and give you the same light actually. So power quality is a issue nowadays. So we can all these topics are different research area basically. You can find hundreds of paper on these topics, and suppose storage itself is an area. If you think want to work on this area, hundreds of papers are available. Now, what is research? Now, research is what same thing is being done by someone else also. You're also doing on the same topic. So but you're improving it somehow. A delta X should be there, means something you have improved in that existing system. So if paper is discussing something that I have done this like this, but ignoring this factor. So you can include that. He has done it by ignoring this. I am doing it by considering this. So what is the effect, right? And he has done it by some other method. You are doing it by some other method, or you are suggesting some other strategy, like price of electricity is there. So what should be the bidding? He has given some idea. But you can give some other idea if pricing is like this, so this is a benefit. So you have improved that. So everything, same thing he has done, same thing you are doing, but you have done some delta X in that. You have improved that existing task on which is already done by someone else. As I told you, electricity was coming earlier also, but that was conventional grid. Somebody might have thought of a smart grid also, right? And that is demand of the future also. When means environmental pressure is there, demand is increasing, and you are not able to handle it. So now, what is the problem with the AC system? You can see that you have to supply more energy, more power, right? Demand is increasing. So what you will do? You will increase the voltage level, because same amount of power cannot be transferred at that voltage level only. Suppose 400 volt was there, the transmission level, 400 kV. Now 765 kV is there. Now 765 kV is also not sufficient. I mean, the demand is further increasing, and new generating stations are coming up. You have to supply more power. And to supply more power, if you are using same voltage level, so losses will be more, or you can say there will be some other problem. You will know, power transmission capability has got limit that is given by V1, V2 by X. So you have to increase the voltage level. Now 1200 kV transmission voltage is coming, right? So it is under installation also, under research also. So, but what is the limit of that? Means up to how much time you will keep on increasing the voltage level. So increasing the voltage level, again the problems are there. Safety is a problem, insulation is a problem. So many problems are there. So you have to go for the smart grid. This is another option. So without increasing the voltage level, means you are what was that? Earlier we used to install the capacitor at the load center. That was supplying the reactive power at the load side only. So that reactive power otherwise would be flowing from the generating station through transmission line coming to you. So that was flowing in the line. So that reactive power is not now flowing in the line, although it is lossless, but indirectly it is increasing the current. Like R plus Ix will be the net current will be more. So that net current is actually I square R loss. So indirectly you are increasing the loss, although reactive power is lossless, you say. But that reactive power is flowing in the line, it is increasing the losses. It is the voltage drop will also be there. I is increasing, so I into R, the voltage drop. So sending end voltage will be more, receiving end voltage will keep on decreasing if you increase the current. So earlier the idea was install capacitor, so that reactive power at least will be supplied locally there, right? Now you are supplying active power also now, means by installing solar power plant or anything. So some of the renewable energy are supplying DC power like solar. But if you go for wind, it will supply AC power. So it is giving you active and reactive power both. So all these are different area. Means if you a lot of scope is there in every point, which this a single point it is visible, but hundreds of paper you will find, and it is a new research area. So new product and services, limited, poor, and customer focus. Now better market and services for the consumer. So right, new products are coming, new equipments you're using, which are automated. Asset optimization. This was poor and little data integration was there, or no data integration was there. Now it is data driven predictive assets management, right? So same assets can be used more efficiently if you are having sufficient data and analysis are there. So when is to be used, when not to be used, when so that same asset, available asset, can be used efficiently if you are having uh, prediction data, historical data is there, and the control is there, analysis is there. Now self-healing, no self-healing was there, now self-healing is there, right? So whenever there is fault, automatic data hai, so what should be done? You can take action. Means it will be done automatically. So that is self-healing. Cyber attack, there was not no vulnerable side. It was cyber attack was possible. Now here it is because having you having जैसे हमारे कंप्यूटर में वायरस होता है, यहाँ भी हम we are immune to that cyber attack. We make it more secure. Disaster management. So when fault is there, how you are managing. So slow and reactive response to the natural disaster, right? ये तो natural disaster का है, but यहाँ quick and predictive or maybe fault, maybe natural disaster, all may be covered in this area. So quick and proactive response to disasters, right? Event analysis, right? Because now suppose यहाँ कहीं पे disaster, हम natural disaster की बात करें तो how it is useful, right? डिजास्टर आ गया, आपको ट्रांसमिशन लाइन कट हो गई है, कोई प्रॉब्लम आ गया, फॉल्ट नाउ पावर इज नॉट कमिंग फ्रॉम that through transmission line for conventional generating station. So you are having local generation. You are having what? At distribution center, you are having your own generation by solar and wind. So power is coming from that source. So although that grid power is not available, so now it is renewable energy resources are managed such a way that they supply the power locally also. So that handling is there. You can say that is islanded mode. So that microgrid can work as a grid connected mode also in the islanded mode also. Or somewhere you can think of some remote area when इंडिया में कई सारे गांव हैं जहाँ पावर नहीं है. So you can install that solar power plant locally there. Also grid is not there. So आप वहाँ पर power supply कर सकते हो by using a small hydel plant or biogas or some other renewable sources. Maybe wind if it is available or sun is available. So whatever is best available, you can supply power to that remote area which is not connected through the conventional grid, you can say. Right? So that way means we can supply power where it is not possible, it was not possible earlier using the conventional grid. Communication, mostly one-way communication, we have already discussed two-way communication here. Predictive, non-predictive process and application, predictive process and application, right? So because of based on data and IT and communication, you can predict so many things. Intelligence, limited or no intelligence was there. Now intelligence is there and integrate with process critical info. Efficiency, naturally efficiency is now focus and it is increased. So all these now new concept when I said ki the smart grid has come, some new terms are introduced and some new concept has arisen. Like prosumer is a new word which is a combination of producer and consumer. Earlier it was only consumer. Now consumer is also producing electricity, so that combination you are now prosumer. You are consuming as well as you are producing, right? So you are having your own solar plant in your house. तो जैसे अभी सबके घर में डिश एंटीना होता है, पीछे आप सबके घर में सोलर पावर प्लांट होगा, right? If sun availability like in Rajasthan is good, so you can use that. So you can generate your own power. You can supply your own load. When your load is less than the generation, you can supply that power to the grid, and you can earn money through that. Now, virtual synchronous generator, right? As I told you, inertia is missing in the solar power plant, right? So that is required for stable operation of the generator. Like synchronous हम आप करते हैं जो दो generator को आप synchronize करते हो. So that is actually to handle that problem. Suppose whenever the active load is suddenly reduced or reactive power demand is suddenly reduced, the speed mismatch will be there. That may go out of synchronism. But the moving part is there in the generator that is having its own inertia, so it can handle some disturbance. up to some limit. But as far as the solar power plants are concerned, some other renewables are concerned, their rotating part is missing. So, new concept, new idea is virtual synchronous generators are being introduced. So that is handling to artificially add inertia through converter controls. So artificial inertia is being introduced. So that is known as virtual synchronous generator. Now, ADMS is Advanced Distribution Management System, and to coordinate distribution management system, and MEMS like microgrid energy management system. So that is a program in computer based that is managing that control actually. Right. So we will be having some idea if we time is there. Microgrid I was discussing demand response also. We have half an hour. We will try to. So I try to finish it early. Coming to the microgrid and control of microgrid is also a chapter which I have to cover today. So distributed energy resources, these are the resources being you can say the distributed generations using renewable technology. The photovoltaic may be there. I mean solar technology can be used to convert that sunlight to electrical powers. But sunlight can directly be used as a thermal unit, right? You can use it to heat up the water or some heating equipment. So solar thermal power can be used directly without converting it into the electrical energy. This is by converting solar power into electrical energy. So photovoltaic cell you are installing, but here solar photovoltaic cells are missing, but you are using solar energy. So that is also having a lot of applications. Small wind system means up to 50 kilowatt. You can install at your home also. Large wind system means ranging from 1 to 2 megawatt. Right? If large amount of as a group you want to install, that can be done. Or by the government, they are installing it. Big wind station, right? So this is smaller one. It may be installed at your home also. It's a larger one. Biomass, etc. So there are so many options, means not all covered here. Now, storage technology is you can store the electricity in the form of mechanical or electrical or chemical form, or this is battery, you can say, or electromechanical form, right? So this can be done. There's so many ways of storing actually, right? In terms of hydel also you can use it. In terms of potential energy also you can store. Like in hydro power plant, what they do, they've installed a small solar power plant, and when the demand is less, power is being generated by solar power plant, so that can be used to uplift the water, you know, and you are uplifting that power when solar power plant is there, the sun is available, but load is not there, so you can uplift it. That water is being uplifted. So that is having some potential energy. It has been converted to the potential energy, and that is being stored in that form. So whenever required, that water can be used in the hydro power station to generate electricity. So in that potential energy is being used. So you can convert that energy into any form. You can store the energy into any form. Yeah, here the potential energy is not rating, so many things, forms you can store. Now, just in having idea of what is being happening in India regarding solar power plant. So National Solar Mission was there, launched in 11th January 2010, had the target of 20 gigawatt was supposed to be installed till 2022. Right? So the meeting was held again in the government change. यहाँ कांग्रेस ने किया था, यहाँ बीजेपी आ गई. They have again increased that target to 20 gigawatt to 100 gigawatt by 2022. So now this is our target. So you can see the website of MNRE, it is Ministry of New and Renewable Energy. So you will see what is the current situation there, how much being installed till date, and how we are going to achieve this target. So that is very well given in that site. So you can visit that site mnre.gov.in. You can see. So as on this data is taken from that only. As on 31/3/19, the total solar power capacity installed is this much megawatt. In addition, the capacity around this much megawatt under installation, and this much standard watt issue like 100. अभी हो सकता है as on today some more it has been increased. This is up to 31st March 2019. So 1 year has been gone by that. So based upon the availability of the land and solar radiation, the potential of solar power in the country has been assessed to around इतना हमारे पास है means 750 gigawatt peak is the capacity in our country based on the land and solar radiation available for this. This is what state-wise I have shown some top 7 states which are having how much capacity is being installed by this date, and this is total capacity of India. Means I have taken only top 7. So Rajasthan is here and MP is here, right? In terms of solar. Similarly, you can see the data of wind and other renewables also in the source I have given mnre.gov.in, right? Ministry of New and Renewable Energy. So they are dealing only with the renewable energy, not the conventional one. Now this is a smart grid network. You can see what is a part of the smart grid. You can see generation is there, conventional generation. Wind farm has come and solar farm means large solar power plant and large wind farms installed by the government to generate large amount of power that is directly connected to the transmission system. So this conventional plus this renewable is connected to the transmission, and that is the big installation you can say in terms of megawatt and in that range. Now distribution is there. So at substation you may have their energy storage, their own energy storage, and you can have some smaller solar plant also here. And this is distribution network. Now in this distribution network, the microgrid comes in this part. Means these are smart. This is complete as a smart grid. This is all these components are the part of the smart grid. Microgrid is a part of the smart grid, which is at you can say in terms of capacity, smaller smart grid you can say. So at a distribution level, whenever this is there, that is called microgrid. So microgrid may be having maybe a combination of solar and wind and other things. Storage also is there. So many things are there. So you can have smaller grid at the level of distribution network. So these are all loads. Rooftop solar, a consumer can install their own solar plant. Large wind farm may be there. EVs are coming. So this is again a new concept. Electric vehicles. So electric vehicles means they are having their own battery, but एक simple storage permanent connected that is different means permanently connected that batteries are 24 hours available. But EVs sometimes it may be connected to the grid, sometimes they are on the road, so they are not supplying. So the concept of EVs are different. आप घर में आके आपने रात को चार्जिंग पे लगा दिया and you have given the permission to utility to utilize your battery also. So whenever required, they can take the power from your battery, and whenever not required, you can use it to charge your battery also, right? And you can have your own home management system. So when vehicle is connected to your home, so in between that some control is there that is being controlled by your computer system or IT. So based on the price, it can reschedule the charging and discharging of your battery. So whenever demand is more and vehicle is connected, you can take that power to supply your load also. And when price is low and load is also low, you can utilize that energy to charge your battery of your vehicle, right? But when you are in office, again you are going to the office and again you are connecting your vehicle at the parking. So again, the same way it can be utilized by the utility. So whenever demand is peak and those vehicles are connected, right? So it will just check your battery charging level is more than this, it can be utilized to. So some power it will leave to start your vehicle actually. So when vehicle is started, it will be charged again. The battery can be charged automatically. So it will leave some energy in that. So that limit is defined. So when charging is more than that, you can give it to the utility, and that amount will be paid to you. So some system will come in future. So many concepts are there for electric vehicles. So again, it is a different research area. Now, renewable generation, few technical challenges. What are the problems? What are the challenges? When these challenges means the research ideas, and you can work on these topics. So, need accurate forecasting, intermittent generation dependent on weather and season. As I told you, so renewable generation is dependent and it is not confirm. It is intermittent in nature. अभी यहाँ धूप है, थोड़ी देर बाद बादल आ जाएंगे, पता नहीं क्या होगा. What will happen after 1 hour? है ना? You don't know. Even forecasting sometimes go wrong. So forecasting तो approximate है, but exactly क्या होगा you don't know. So we work on based on the forecasting. If forecasting technique again is a research area. So how to forecast weather based on the existing data. So how accurate is your forecasting? That is very important in terms of renewable. If it is accurate, accordingly you are prepared for that. So how much energy will be available through solar or wind is known to you. So you can plan what should be the conventional energy, means what other generating plants, how much power is to be generated by those. Suppose आपने प्लान किया कि कल सन होगा और इतना पावर हमें जनरेट करना है, यू आर प्रिपेयर्ड, या आपने 2 यूनिट बंद कर दी जनरेटिंग प्लांट्स, दो जनरेटर्स को शट डाउन कर दिया कि इतनी जरूरत नहीं है. सडनली सपोज क्लाउड्स आर देयर and suddenly that power is now gone which was expected. Now you have to, है ना? So there is a ramp rate, means आपको जनरेटिंग स्टेशन वापस ऑन करने के लिए उन जनरेटर्स को it takes time. So you are not prepared for that. So if forecasting is not accurate, right? So these generation through renewable is intermittent in nature. That is that. So again, as it's a research area, you can work on that forecasting. You can work on the intermittency of generation. So how to handle that. So if suddenly it will go, so that load will directly come to the conventional power plant. Thermal power plant पे load आएगा एकदम से. वो they are not prepared for it because forecasting was not like that. So voltage and frequency control, many of these sources do not have reactive power generation. As you know, solar power plant supplies only active power. So you have the reactive power is not there. So you have to install some capacitor to supply reactive power. So the combination of the solar and capacitor can supply both active and reactive power, and the voltage and frequency control may be there. Sudden generation loss can lead to system instability, as I told you, है ना? तो आपको मान लो एकदम से पूरा जयपुर का या पूरे सिटी का लोड एकदम से खत्म हो गया, so that load will come to the thermal power plant. So there rotating generators are there. So active load demand suddenly will increase. That will reduce the speed of the generation. So that control, if it is beyond that control, the change is lot more than some certain limit. So that generator may go out of synchronism. If that one generator goes out of synchronism, again it creates problem on some other generating station. So it is a cascade effect, you can say. So complete blackdown may be there. So that is there. So you have to be prepared for that. So these are the challenges. Means we are going for renewable. It is good. Means an environmental friendly. It is, and so many advantages are there. But at the same time, some challenges are there. Some disadvantages also there. So also inertia less generator has inertia nahi hai. Rotating part is missing. So that is a problem with the stability problem. So those who know what is the stability problem and working in that area, so they can select this topic. पावर क्वालिटी इश्यूज मीन्स नेचुरली आपका सोलर जो है डीसी जनरेट करता है, हमारे ग्रिड को एसी चाहिए. So DC load can be directly supplied. DC microgrids are also there, like heating load and other load, charging load. आप अपने लैपटॉप मोबाइल चार्ज करते हैं, उल्टा आप वो एसी को डीसी में कन्वर्ट करते हैं. आपका हीटर है, आपका वाटर हीटर है या हीटिंग एलिमेंट्स हैं, इंडस्ट्री में भी जो हीटिंग पार्ट है, दैट कैन यूज द डीसी पावर डायरेक्टली. So but most of the equipments, most of the things are AC. So you have to convert that DC, which is generated by the solar system, into the AC. But that will not be 100% sinusoidal. So whenever anything is not sinusoidal, harmonics are there, flickers are there, under voltage, right, through the capacity. So all these problems will be power quality issues will be there. So you have to convert that DC to AC and should be complete sinusoidal AC. That is a challenge. So you have to make that. So if it is pure sinusoidal, that is what is required. If it is not pure sinusoidal, so harmonics are there. So you have to filter those harmonics. You have to connect filters and right. So you have to avoid that. Again, to rectify these problems, you have to install so many new things. Filters has to be installed. So that will increase the cost. Means solar की वजह से आपको converter भी लगाना पड़ रहा है, which is inverter you can say, which is converting your DC to AC. You have to install some filters also, right, to eliminate these harmonics. So additional installation will be there, so the cost will increase accordingly. But that is one-time investment. So you have to use battery also because solar power is available in the daytime, but power requirement is more in the night. So you have to save that electricity in terms of storage. So you have to install some battery also. Power management and maximum power point tracking, right? So ये आपको manage भी करना है. मैक्सिमम पावर पॉइंट ट्रैकिंग मीन्स आपका सोलर जो सेल है वो सन के साथ साथ मूव होता रहेगा तो आप उससे ज़्यादा पावर एक्सट्रैक्ट कर सकते हैं. सो इफ इट इज कमिंग इन पर्टिकुलर डायरेक्शन सो इट विल इंक्रीज more power will be generated. So that is there. Power management is there. Requires proper converters and controllers. So we'll see the control of microgrid in that. We'll see that some major challenges in the smart grid, reliable and fast communication, big data, cyber security, right? So these are again big data is a challenge because आपका data तो आ गया लेकिन उस data को analyze करना और उसको data को proper utilize करना is a big issue. है ना? हर सेकंड में डेटा आ रहा है, 10 सेकंड में डेटा आ रहा है. So lot of data stored, but उसका जो यूजफुल डेटा है वो क्या है उसको एनालाइज करना उसको वो दैट इज अ डिफिकल्ट टास्क एंड बेस्ड ऑन दैट डेटा यू हैव टू टेक सम डिसीजन इज अ डिफरेंट डिफिकल्ट टास्क. साइबर सिक्योरिटी इज आल्सो अ चैलेंजिंग टास्क बिकॉज अब आपका सब कंप्यूटर सिस्टम है, एवरीथिंग इज थ्रू कंप्यूटर, सो उसमें भी आपका अटैक हो सकता है जैसे है ना, तो दैट प्रॉब्लम इज देयर. Somebody may attack your system and may misuse your system or and they can shut down your system and they can disturb your system, right? So threats are there also. So wide area monitoring system integration with EMS and SCADA DMS, right? So SCADA is a data management system. So all these things should be installed, right? Existing network to evaluate network stability, ampacity of the line, and detection of critical network condition. तो ये सब चीजें आपका डेटा से कंट्रोल होगा कि आपका स्टेबल होगा कि नहीं सिस्टम बेस्ड ऑन द डेटा अवेलेबल. Ampacity means the current carrying capacity of your line. If it is increasing, so you have to control, you have to divert some load to some other area. So that ampacity may be within the limit. Detection of critical network condition, right? So all these things will be done by these control system actually. So that will be analyzing your data. And based on that, all these things will be analyzed. Suitable converter topology, control of RES, that is renewable energy resources integration, right? So that is again means proper controller design करना उसको. Control means control of RES means कम किससे पावर लेना है, किसको पावर देना है, कब बैटरी को चार्ज करना है, कब डिस्चार्ज करना है, लाइक दिस है ना, तो कितना पावर लेना है. इफ इट इज टू बी कंज्यूम द लोड वी हैव टू सप्लाई टू द ग्रिड. So that control should be there. Power flow should be properly controlled in which direction it should flow. The battery is half charged, it can be used for the supply also, it can be used to charge that battery also, right? So in that midway means that control should be proper, whether in which direction the power should flow, whether it should charge the battery or it should discharge the battery, right? Whether you are taking the power from the grid or you want to supply the power to the grid. So two-way things are there. So your meter should also be recording the two things: how much energy you have purchased, how much energy you have supplied. So both way. So everything is two-way now. Optimal siting, sizing, and control of energy resources, right? Now when we are talking about distribution system, so वो जो है उसकी साइटिंग मतलब किस लोकेशन पर आपको सोलर प्लांट लगाना है, उसका साइज कितना होगा, that optimal size and siting you have to decide which will be most economical or most optimal location or optimal size, you can say, and control also. So all these things are different areas we can work on this. Lot of papers are available on this siting sizing problem only. So dealing with intermittent generation, as I told you, flexible generation, high ramp rate. CHP is combined heat and power, means excess heat is being utilized in this. And thermal storage means you can use electricity in the form of thermal also, thermal form. You can heat up something in that time. And whenever required, you can use that heated thing. Means आपने suppose steam जनरेट करना होता है थर्मल पावर प्लांट में, अभी एक्सेस पावर आ गया, उसको आपने वाटर को हीट करने के लिए यूज कर लिया. That heated water can directly goes to the boiler where it can produce steam. So that heat is being utilized. So you have stored the energy in the form of heat. So any form you can store. So that is being done in the CHP plants actually. So again, it's a different area. So adaptive protection in active distribution network. Protection again is an area, right? अभी आपका जो है relays are different one way. Now two-way supply will be there, so different protection system is to be installed. And है ना, DC protection is difficult because there is no natural zero. In AC there is a natural zero, so you can isolate the circuit breakers very easily. But in DC there is no, so artificial zero is to be created. So that protection is challenging. Actually, it is difficult as compared to AC circuit breakers. So to break the DC current is a difficult task because there is no natural zero available. So again, it is a different area. Protection itself is a different area. What will be the protection system when microgrids or small grids are there, when two-way power is flowing? So what should be the protection system? Because earlier protection system is designed for one-way flow only in distribution. So as you know, distribution system is normally arranged in mesh and but operates in radial system because only one-way power flow will be there. But now radial may not be required because power is flowing in both the directions. You can operate in mesh also. So transmission system is always in mesh, but distribution is designed in mesh but operates in radial system because of the protection system, because of the economical protection system. Although protection may be provided for the mesh distribution network also because in transmission it is designed for the mesh. But distribution system is more complicated and more number of relays and circuit breakers are to be installed because two-way, both the sides it will be connected. So those who know protection subject easily, they can understand what I mean. So again, this means what will be the protection system with when the power is flowing in both the directions, means consumer is also producing power. Power is also being produced at a distribution level. It is not only coming from one power plant through transmission line, one way only. So it can be generated locally also. So power is coming from other direction also. Right? So the protection system has to be redesigned. Regulatory change means these rules are being changed by the utility now. Right? They are allowing the private vendors to come in. So what will the rule means? They have to also follow some rule, means they can provide power, but these are the restrictions, these are the rules. So इससे ज़्यादा पावर आप नहीं देंगे, इससे कम नहीं देंगे. आपको मेरी आपने प्रॉमिस किया कि हमको गर्मी में 12 बजे इतना पावर आप दोगे. So that is all thing is recorded actually. So when you are not able to supply, you will be having a penalty. So all these rules is to be decided, means regulatory change you have to make. अभी तक वो नहीं था. So when private vendors are coming, they are also supplying power. You have to change your rules also. So regulation change is also there. So these are also challenges. So consumers' acceptance to RES development and demand side participation in social survey, right? Up user can also participate in this. User is supplying power, right? So आप डिमांड रिस्पॉन्स अभी एक टॉपिक आएगा मेरे इसमें मेरी है, तो अभी टाइम कितना हुआ? 12 लगभग बजने ही वाले हैं। चलो कल वाले में कवर करेंगे। ये कुछ चैलेंजेस हैं ट्रांसमिशन के, सिंक्रोनस टेक्नोलॉजी, मोटिवेशन, वी कैन स्किप दैट। ये व्हाट इज गोइंग ऑन इंडिया में, क्या क्या है, डिफरेंट सेटअप्स आर बीइंग जस्ट फॉर स्मार्ट ग्रिड दे आर मींस, है ना। सो दिस इज अ बॉडी created in 2010 that which will advise the ministry about the smart grid, right? So Indian Smart Grid Forum is being, so all these bodies being created for that. They are working on smart grid problems and, you know, discussing with the ministry and how to actually, you know, make that smart grid a reality. They are working on that. Technology required for smart grid. So I can give you the slide. You can go through that. Smart grid in India. So this is just an information what is happening nowadays. So I think sufficient for today. Tomorrow I will try to cover that control of microgrid and electric vehicle part, which I could not cover today. I wanted to cover the microgrid and control of microgrid also, our demand response part also. But I think the time is already over. Even I have to go somewhere. So we can stop here. So if time allows, we will discuss these slides also, which I skipped today. So this is some conclusion which we have already discussed actually. So we can stop here. So
can we ask the participants for query? Sir, can we ask the participants for questionnaire?
Sure. But they can contact me anytime. मैं वो मीट वाला वो पेज मुझे मिल नहीं रहा, कहाँ गया? Okay.
So participants, if you have any query, any question regarding this presentation and this topic, you may ask, you may clarify, and you can add more to your knowledge.
Any query you can ask anybody, but you are free to ask afterwards also. I think Shalini and Nidhi can provide you my mail ID and other contact details, because I have to go to college also, because I am having responsibility of associate dean also. So if you have some query, if I can answer, just know you can ask. But later on also you can contact me anytime. You can go through my papers. You can see my papers on Google Scholar. It is available. If you search Anil Sarankar on Google Scholar, you will see my papers. Okay. Any query if you want.
So can I summarize your talk in few words?
Summarize though, I already summarized in various slides that smart grid means basically we are going from conventional grid. What is your question basically? Means that is the main, means how we are going from conventional grid to smart grid. What is the difference? That was the main coverage today actually.
Yeah, that was the main comparison between this conventional and smart grid on the major points like architecture and generation and storage options, quality of
each slide you can have. My aim was to introduce a lot of research areas are there basically. So there are different terms, and each term is a different research area. So what is the purpose of faculty development program is that to find some new area, because I got my idea also from some similar program actually. So when I was doing PhD, so those who are doing PhD, they can get some new ideas, and they can search a lot of papers on different areas which we have discussed, and depending on their interest, they can uh, choose their area and they can work on that. So what is going on in the scenario of smart grid, and what are different features we have discussed?
Okay, sir. Thank you very much, sir.
Thank you, Anil.
Request. Yes,
Thank you.
Nidhi ma'am.
Anytime. Because
thank you.
जबलपुर से मैं
Thank you.
connected हूँ, I feel honored, and it is my pleasure actually to get connected to Jabalpur in any form actually. So
Thank
Nidhi
you,
knows
Anil.
this very well.
Participants are very happy, and in the chat box they are giving very good comments. So we
Thank
are
you so much. You
thankful to
share
you.
those comments to me later on. So
Ah,
we have
yes.
class tomorrow also. So I will try to cover the microgrid part and control of microgrid and demand response, which I wanted to cover today, some of them, but I could not. So we'll continue tomorrow. So any question
Yeah.
from today's slide also you can discuss tomorrow. But I was just
Sure.
discussing some basic things, right? In depth, there are a lot of things because even I am not expert of all these areas, right? But I have given you the idea. Those who are working in that area, that then they can work. So what is going on in the area of smart grid, you come to know today actually.
Okay, then. So should we conclude now?
Sure.
Okay. On behalf of Electrical Engineering Department in Gyanaganga Engineering College, I convey my sincere thanks to Dr. Anil Swankar sir for delivering such an informative session on this smart grid implementation. Thank you very much. Sir.
Thank you so much for inviting and giving me this opportunity.
So tomorrow again we will meet at the same time for more information and hope.
I'm leaving now. Okay, thank you.